Why, even thousands of years ago, did people look up at the night sky and see more than just dots of light? They saw gods, animals, messages, and even their own destiny. And today, in the age of rockets and telescopes, the stars continue to fascinate us. Not just romantically, but scientifically. Because when we look into the sky, we're actually looking into the past, and possibly into our future. What is a star? A star is a huge glowing sphere of gas, mostly hydrogen and helium. In the core of a star, an incredible process happens. Nuclear fusion. Hydrogen atoms collide and fuse into helium, releasing colossal energy. That's what makes the star shine. Our sun is one such star. Big, hot, and vital. Without it, there would be no light, no warmth, and no life on Earth. The life of a star, a cosmic biography. Stars are born, live, and die, just like us. Only their lifespans are much longer. They form from giant clouds of gas and dust, nebulae. Under gravity's pull, this matter contracts and begins to heat up. A protostar is born. Then, if the mass is sufficient, nuclear fusion ignites, and the star begins its life cycle. Small stars can burn for tens of billions of years. Large stars, only for a few million. But the bigger the star, the more spectacular its death. What happens when a star dies? A small star like our sun becomes a red giant, then sheds its outer layers and turns into a white dwarf, a dense, hot core the size of Earth. A massive star explodes in a supernova. The explosion hurls matter into space, and what remains becomes either a neutron star or a black hole. These explosions aren't just spectacular, they are cosmic forges. In the heart of a supernova, all the heavy elements are created. Oxygen, iron, gold, uranium. Everything that makes up our planet and our bodies. You and I, literally made of stardust. How many stars are there in the universe? Astronomers estimate that there are more stars in the universe than grains of sand on all the beaches on Earth. Billions of galaxies. Each galaxy contains billions, sometimes trillions, of stars. And here comes the most important question. How many of them have planets like Earth? And how many of those could harbor life? Thanks to space telescopes like Kepler and James Webb, we've discovered thousands of exoplanets, planets outside our solar system. Some of them are very similar to Earth. The right temperature, the presence of water, even potential atmospheres. If even 1% of stars have Earth-like planets, and if even 1% of those have conditions for life, that's still millions of potential worlds with living organisms. But why haven't we found anyone yet? Stars group into huge families, galaxies. Each galaxy contains hundreds of billions to trillions of stars. Our Milky Way is a spiral galaxy, like a giant cosmic whirlpool. At its center is a supermassive black hole, and far out on one of its spiral arms, like the suburbs of a cosmic metropolis, is our solar system. Galaxies come in many shapes: spiral, elliptical, irregular. Sometimes they collide, creating chaos, birthing new stars and transforming themselves completely. These collisions take millions of years, like slow dances on the edge of eternity. The cosmos as a laboratory for life. If stars forge chemical elements and galaxies form worlds, then the entire universe works like a giant factory, producing the possibility of life. But where is everyone? This is the famous Fermi paradox. Billions of stars, billions of planets, and no confirmed contact. Why? There are many hypotheses. Maybe intelligent life is rare. Maybe civilizations destroy themselves before they can explore the cosmos. Maybe they are too far away, or use communication methods we can't detect. Or maybe they're avoiding us for the same reasons we don't talk to ants. Some scientists even suggest that intelligent life could exist in forms we don't recognize. What might alien life be like? We tend to imagine beings with eyes, limbs, and faces, but life on other worlds may be nothing like life on Earth. On high-gravity planets, creatures might be flat and squat. In methane-rich atmospheres, life might use liquid methane, not water. On tidally locked planets, With one side always facing the star and the other in darkness, life could evolve uniquely on the twilight line between day and night. Even more exotic possibilities exist. Life based not on carbon, but on silicon, or non-biological life, energetic, plasma-based beings living inside stars or clouds. Consciousness as a cosmic phenomenon. What if consciousness isn't a fluke, but an inevitable outcome of evolution? Then intelligence might arise again and again, wherever conditions allow. Some philosophers suggest the universe is trying to become aware of itself, and intelligent beings, like us, are the mirror it uses to look inward. How much time do we have? Our sun is middle-aged. In about 5 billion years, it will become a red giant, engulf the Earth, and eventually become a white dwarf. But long before that, in about 1 billion years, Earth will become uninhabitable. The sun will get hotter, oceans will evaporate, and life will disappear, unless we find a way to leave Earth. Colonizing the cosmos, fantasy or necessity? Many scientists believe if humanity wants to survive long-term, it must become a multi-planet species. We must colonize the moon, Mars, Jupiter's moons, build bases, terraform planets, and search for Earth-like worlds beyond our solar system. It's not just romantic science fiction, it's a survival strategy. We're only taking our first steps, but we're already building telescopes that can find habitable planets, designing spacecraft that can travel for decades, simulating habitats on other planets. What happens after the stars? Stars don't live forever, and neither do galaxies. The universe is slowly, inevitably heading toward its end. Right now it's expanding, and that expansion is accelerating. Galaxies are drifting farther and farther apart. In the far future, stars will stop forming. Existing stars will burn out, and the universe will enter the dark era, cold, silent, and empty. This is called the heat death, when energy is so evenly distributed that nothing can happen anymore. No life, no light, just stillness. But that's just one theory. Others include the Big Rip. If dark energy grows stronger, the universe could be torn apart. Cyclic universe. After death, the universe might collapse and be reborn again. Or something entirely beyond our imagination. What does all this mean for us? When we look at the stars, we're looking into the past. Light from the nearest star takes over 4 years to reach us. From distant galaxies, millions, even billions of years. The sky is a time machine, a cosmic archive, and in that archive lie the answers. Where we came from, where we're going, whether we're alone. We are the children of stars. The elements in our bodies, our breath, our minds, were all created in the hearts of stars. We are literally star stuff. We are the only known case in which the universe became conscious of itself. Maybe there are others, maybe not. But for now, we are alone. And it's up to us to decide how long that consciousness will last. Why questions matter. Science is a journey, a quest. And every discovery brings us closer to understanding. We may not know exactly how life began, but we do know the universe is not empty. It's active, evolving, full of potential. Maybe right now, on a distant planet, a living creature looks up at its own sky and wonders, is anyone out there? And in that question, there is hope. Hope that we are part of something greater, that our consciousness is not an accident, but a chapter in a larger story, that we are not just temporary guests on a small blue planet. We are witnesses and keepers of the greatest story ever told. And as long as we look to the stars, search, and dream, we are alive.